In this video, we'll go through some examples of circuit breaker. And in recent years, as you can see in the pure physics 2016, 22, and 24, the diagram seems to be a bit more complicated, usually involving moments. But the working principle of the circuit breaker still remains the same. But the thing is, you really have to analyze the diagram carefully to understand how it works. Therefore, you can answer the question. And in this video, we'll just focus on these two examples. In this question, you have a circuit breaker here, and the circuit breaker breaks when the current is larger than 30 ampere. That means to say the rating of this circuit breaker is 30 ampere. Anything less than 30 ampere, the current can just flow through and it won't trip. Before we go through the first question, how the circuit breaker breaks the circuit where the current exceeds 30 ampere, maybe let's understand how it works when the current is within the limit 30 ampere. Let's assume the current flowing through the circuit is 20 ampere. So that means to say it's within the limit. So 20 ampere of current will flow through here, the contact, pass through the pivot, then go through the coil, and then go out to your appliances. Because 20 ampere is within the limit of 30 ampere, it will just flow through and the circuit breaker will not trip. But one thing that you need to take note is when the 20 ampere is flowing through right now, the iron arm will not be attracted. But the thing is, this iron core will still be magnetized. It is already magnetized, just that it's not strong enough to attract the iron arm. And for this question, since the weight of the iron arm is not given to you, you can ignore it or treat it as negligible mass. Or another way of thinking is the pivot is at the center, the weight of the iron arm is here. Since the line of action of the weight passes through the pivot point, the weight of the iron arm will not create any moment about the pivot. Now, as mentioned just now, the iron core, it is magnetized, just that not strong enough to attract the iron arm. But so there's an attraction force and it's acting downwards on the left hand side of the iron arm and it's creating a anti-clockwise moment about the pivot. Next, let's talk about the springy matter, and indeed, this is part of the question, what's the purpose? Now, you have to understand that the iron arm has to be maintained in this position so that the upper and lower contact must be touching each other so that when the current is within the limit, let's say 20 ampere, this has to be in contact to allow the current to flow through, allow the appliances to work. So as mentioned, there's already a traction force on the iron arm by the iron core, creating an anti-clockwise moment. So you have to understand that the springy matter is exerting a downward force that will create a clockwise moment about the pivot. Another way of looking at it is I can also replace the springy matter with a spring that's pulling the right side of the iron arm downwards so as to create the clockwise moment. So as you can see, both methods, they are doing the same thing. Now let's erase this. Now one thing to take note is, even though the question did not mention, you are supposed to know that these two are not the only forces that's acting on the iron arm. So if student were to think that right now the only thing that keep this iron arm in equilibrium horizontal is because the clockwise moment due to the force by the springy matter is equals to the anti-clockwise moment due to the attraction force by the iron core, that will be wrong. Because if these two moments are equal and this thing is equilibrium, there might be a chance where this upper and lower contact is not touching one another because it's balanced, exactly balanced, so this thing may or may not touch. And that's the risk there. So if there's a small gap, then spark might be produced and it might be a hazard. So you must understand that this springy matter actually push down more to make sure that this contact here, the upper and lower contact, are being forced to come together. So there is also a force acting downwards by the upper contact on the left side of the iron arm. So that force is going to create your anti-clockwise moment also. So now, as long as we understand the purpose of this springing matter and the fact that there must be a downward force on this side here on the iron arm, we can go ahead and answer the question. Now, the first question asks you how the circuit breaker breaks the circuit. So let's go through step by step. So the first thing is to say that when the current due to an electrical fault, only when there's an electrical fault, the current will exceed. So you must mention that the current is higher or exceeds the 30 ampere rating. So if I were to draw the current flow here, flow through here, pass through here, and that current is higher than 30, you must say that the iron core is more strongly, okay? You have to do a comparison, more strongly magnetized. Now, what's the mistake by student is they say that when the short circuit current flow through that's higher than 30 ampere, the iron core becomes magnetized. Fundamentally, that's wrong. As mentioned in the earlier part of the video, when a current of 20 ampere within the limit flows through, when current flows through the coil, the iron core itself will be already magnetized. It's just that now when the current is much higher, greater than the 30 ampere, it will be even more strongly magnetized. So this will cause the iron arm to rotate anti-clockwise. So if you're able to tell me whether based on the diagram it rotates clockwise or anti-clockwise, please do so. And in this case, it's anti-clockwise. And as it moves off, this downward force, the contact is open already. There's no downward force acting on the arm. Of course, this anti-clockwise movement by the upper contact on the lower contact will be gone also. So the contact will now be open and the current will be cut off, therefore it breaks the circuit. Next part of the question, they actually ask you for the purpose of the springy matter. So as mentioned, the springy matter is exerting a downward force on the iron arm and is creating a clockwise moment. All right, and this is to actually to counterbalance the anti-clockwise moment due to the attraction by the iron core and also the anti-clockwise moment due to the force acting down by the upper contact on the lower contact or on the left side of the iron arm. So just take note, if you can understand and mention this part, that will be good, because the contact has to be maintained so as to make sure that there's no gap in between. So you can mention that if this is the purpose is this, so that the contact will be closed when it is less than 30 ampere within the circuit breaker rating. Now, the last part of the question is this. Okay, if the coil were to be replaced by another coil that has more turns, all right, state and explain how this effect has on the current needed to break the circuit. Now, the current needed to break circuit is like the referring to the rating of the circuit breaker. So will it be higher than the 30 ampere or lower than the 30 ampere? So if I were to replace the coil with another one which has more number of turns, you must understand that the magnetic field strength of the iron core will now be stronger. All right, so even though the current flowing through it is less than 30, let's say assuming it's 20, very likely it will be strong enough to attract the iron arm and to break the circuit. So in other words, the current that's needed to break the circuit will be lower, or the circuit breaker rating will be less than 30. So I hope you understand this question better, and if you want the suggested answer, you can click on the link in the description and it will lead you to a blog where I put the suggested answer there. All right, thank you. Let's go to the next question.